In the next exam question, we have a ball A that is vertically projected upwards at a velocity of 16 meters per second from the ground. Ignore all effects of air resistance and use the ground as your zero reference. 3.1 then asks, calculate the time taken by ball A to return to the ground for a total of 4 marks. So ball A is projected vertically upwards with an initial velocity of 16 meters per second. Ball A will then move upwards until it reaches its highest position, where its velocity would be equal to 0. It moves back uniformly back to the ground, where it will obtain a final velocity of negative 16 meters per second. If we choose to take up as positive, the velocity of ball A just before it hits the ground would be equal to negative 16. In 3.1, we were asked to calculate the total time that this ball would be in the air, or the time that it takes for ball A to reach the ground. Looking at our equations of motion, we can make use of the first equation, where we have the final velocity equal to negative 16, the initial velocity equal to positive 16, and the acceleration due to gravity equal to 9.8 meters per second squared downwards. Which gives you a total time of 3.27 seconds that ball A would be in the air. 3.2 asks to sketch a velocity time graph for ball A showing the following on the graph: its initial velocity, the time taken to reach the highest point, and the time taken to return back to the ground for a total of 3 marks. So remember that whenever we draw a graph, we give it a heading. We indicate the axes as well as the units that they are measured in. Now, seeing as my projectile had 2 directions, an upward as well as a downward, the positive part of my y-axis indicates the positive direction which we chose as upwards, and the negative part of my y-axis would indicate the negative direction which would be downwards. Using the velocities that I have, I can draw my velocity time graph. My initial velocity was given as positive 16. Somewhere I reached the highest point, which is 0, and thereafter it hits the ground with a velocity of negative 16 meters per second. The velocity time graph is then given as a straight line. The straight line also indicates the constant acceleration of 9.8 meters per second. So remember from the acceleration formula that acceleration is the change in velocity over the change in time. And when acceleration is a constant, the rate of change would be a constant, and that then gives us a straight line. In the next part, it tells us that 1 second after ball A is projected upwards, a second ball B is thrown vertically downwards at a velocity of 9 meters per second from a balcony 30 meters above the ground. 3.3 then asks, calculate how high above the ground ball A will be at the instant the 2 balls pass one another, for a total of 6 marks. Now ball B is thrown vertically downwards with an initial velocity of 9 meters per second. It will therefore follow a projectile path straight downwards. Ball A is thrown with an initial velocity of 16 meters per second. It will move upwards to its highest point and then move back to the ground. The initial position of ball B is 30 meters above the ground. The initial position of ball A is on the ground and is therefore equal to 0. Somewhere within the projectile path, the 2 balls will reach a final position when they cross one another, and that will be equal in height above the ground. In order to solve this problem, we will have to make use of simultaneous equations. What we need to know is where is the final position when these 2 balls cross one another. Equation 2 and 4 both have the change in position, but we don't have the final velocity when these 2 balls cross one another. Therefore, equation 3 would be best suited in order to solve this problem. We apply equation 3 for both balls separately. We now have an equation that represents the motion of ball A, where I have 2 unknowns, both the change in time as well as the final position. I now call this equation 1. Now looking at equation B, it started from an initial position of 30 meters, but it was only thrown 1 second after ball A was already projected upwards. So the delta T of B we can write as delta T minus 1. That means that if bull A is already 2 seconds in the air, bull B would only be 1 second in the air since it was thrown 1 second after bull A. Now just remember that we take this initial velocity as negative, seeing as this is moving in my downward direction, and we took upwards to be positive, therefore all vectors in the downward direction should be negative. We can now simplify this equation by subtracting and adding like variables. And I can call this equation 2. Now, seeing that the final position of ball A and the final position of ball B should be equal when they cross one another, I can set equation 1 equal to equation 2. It then takes ball A 2.24 seconds to pass ball B. We now take this time and substitute either into equation 1 or equation 2. At a height of 11.25 meters, ball A will pass ball B.